Artificial intelligence, or AI, is a branch of computer science. It aims to create machines that can perform tasks that typically require human intelligence. These tasks include learning, problem-solving, and decision-making. AI systems are designed to analyze information, recognize patterns, and make predictions or take actions based on the data they process. Imagine a world where machines can understand our language. They could even compose music and create art. This is the promise of artificial intelligence. It has the potential to revolutionize many aspects of our lives. AI is already present in many technologies we use every day, from search engines and social media algorithms to self-driving cars and medical diagnosis systems. Understanding AI is becoming increasingly crucial as it continues to shape our world. This essay will explore the evolution of AI from its early beginnings to its profound impact on our lives. We will delve into the key milestones, influential figures, and the potential trajectory of this transformative technology. The idea of artificial beings with human-like intelligence has captivated our imaginations for centuries. From ancient myths and stories of mechanical men to early science fiction literature, the concept of creating thinking machines has intrigued thinkers and inventors throughout history. One of the earliest examples is the story of Talos in Greek mythology, a giant bronze automaton created to protect the island of Crete. This myth highlights the enduring human fascination with the possibility of creating artificial beings. During the Enlightenment, philosophers and mathematicians began to explore the nature of thought and reasoning. They laid the groundwork for the formal study of artificial intelligence. Gottfried Wilhelm Leibniz, a 17th century mathematician and philosopher, developed a system of logic that would later influence the development of symbolic AI. These early explorations into the nature of intelligence and the potential for creating thinking machines paved the way for the emergence of artificial intelligence as a formal field of study in the 20th century. Alan Turing, a British mathematician and computer scientist, is widely considered the father of artificial intelligence. His groundbreaking work in the mid-20th century laid the foundation for what we now understand as AI. His seminal 1950 paper, Computing Machinery and Intelligence, introduced the Turing test, a thought experiment that proposed a way to measure a machine's ability to exhibit intelligent behavior. This paper was revolutionary, as it provided a concrete method to evaluate machine intelligence. The Turing test involves a human evaluator who engages in a natural language conversation with both a human and a machine, without knowing which is which. The evaluator's task is to determine which participant is the machine based solely on the conversation. If the evaluator cannot reliably distinguish the machine from the human based on their responses, the machine is said to have passed the test. This concept was groundbreaking because it shifted the focus from the machine's internal processes to its external behavior. The Turing test has been influential in shaping the goals and aspirations of AI research. It has provided a clear, albeit challenging, benchmark for what it means for a machine to be considered intelligent. It has also sparked ongoing debate about the nature of intelligence and consciousness. Philosophers, scientists, and engineers continue to discuss whether passing the Turing test truly signifies intelligence or merely the imitation of it. While the Turing test has its limitations, it remains a significant milestone in the history of AI. Critics argue that it does not account for other forms of intelligence, such as emotional or creative intelligence. Turing's work laid the foundation for the development of artificial intelligence. His ideas have influenced countless researchers and have been the bedrock upon which modern AI is built. His ideas continue to inspire and challenge researchers today. The questions he raised about machine intelligence are still relevant and continue to drive the field forward. His contributions have had a lasting impact on the field. Alan Turing's legacy is not just in his theories, but in the ongoing quest to understand and replicate human intelligence in machines. Section 4. The Dartmouth Workshop, The Birth of AI. The term artificial intelligence was coined in 1956 at the Dartmouth Workshop. This pivotal event, organized by John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester, brought together leading researchers from various fields to discuss the potential of creating thinking machines. The Dartmouth workshop is considered the birthplace of artificial intelligence as a distinct field of study. The attendees shared a common belief that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. The workshop generated significant excitement and optimism about the future of AI. It led to the establishment of key research centers and funding for AI projects. The Dartmouth workshop marked the beginning of a period of significant progress in AI research. This gathering of brilliant minds set the stage for decades of exploration and innovation in artificial intelligence. Section 5. Early AI, Symbolic Reasoning and Expert Systems. The early decades of AI research focused on symbolic reasoning and the development of expert systems. These systems were among the first attempts to create intelligent machines that could mimic human thought processes. Symbolic AI systems represent knowledge and information using symbols, such as words, numbers, and logical operators. These symbols are manipulated through a series of rules and logical operations to derive conclusions or solve problems. These systems use rules and logic to manipulate symbols and solve problems. The process involves encoding human knowledge into a format that the computer can process, allowing it to perform tasks that would typically require human intelligence. Expert systems, a prominent application of symbolic AI, were designed to capture the knowledge of human experts in specific domains. They aimed to replicate the decision-making abilities of a human expert by using a comprehensive knowledge base. These systems use a knowledge base of facts and rules to provide advice and make decisions. The knowledge base is often created through extensive interviews with experts and the analysis of their decision-making processes. Examples of early expert systems include Dendral, which assisted chemists in identifying organic molecules. Dendral was one of the first expert systems and demonstrated the potential of symbolic AI in scientific research. Another notable example is Mycin, which helped diagnose bacterial infections. Mycin was particularly influential in the field of medical diagnostics, showcasing how expert systems could be used to improve healthcare. While symbolic AI and expert systems achieved notable successes, they also faced limitations. One major challenge was their inability to handle uncertainty and ambiguity, which are often present in real-world situations. They struggled to handle uncertainty, common-sense reasoning, and learning from the large datasets. These systems were often rigid and inflexible, unable to adapt to new information or changing circumstances. These limitations led to a period of reduced funding and interest in AI research, known as the AI winter. During this time, many researchers and funding agencies became disillusioned with the progress of AI, leading to a slowdown in advancements. Despite the challenges, early AI research laid the groundwork for later breakthroughs in machine learning and deep learning. These new approaches addressed many of the limitations of symbolic AI by using data-driven methods to learn and adapt. These approaches would revolutionize the field and lead to the resurgence of AI. The development of advanced machine learning technologies has enabled AI systems to achieve unprecedented levels of performance and has reignited interest and investment in the field. Section 6. The AI Winters, Challenges and Setbacks. The history of AI is not a linear progression of uninterrupted success. Instead, it is a story marked by significant highs and lows, with periods of rapid advancement often followed by times of stagnation and decline. The field has experienced periods of rapid progress, followed by periods of reduced funding, disillusionment, and setbacks, known as AI winters. These winters have been pivotal moments in the history of AI, shaping the direction and focus of research. These winters were often triggered by unmet expectations, technological limitations, and a lack of computational power. The ambitious goals set by early AI researchers often outpaced the available technology, leading to frustration and a re-evaluation of the field's potential. One such winter occurred in the 1970s, following the Lighthill Report in the United Kingdom. This report was highly critical of the progress made in AI research and questioned the feasibility of achieving the lofty goals that had been set. This report criticized the progress of AI research and led to significant cuts in funding, The impact was felt across the AI community, with many projects being shelved and researchers struggling to secure financial support. Another AI winter occurred in the late 1980s and early 1990s, partly due to the limitations of expert systems and the collapse of the market for specialized AI hardware. Expert systems, which had been heralded as the future of AI, failed to deliver on their promises, leading to widespread disillusionment. During these periods of reduced funding and interest, some researchers continued to make progress. Despite the challenging environment, they remained committed to advancing the field, often working with limited resources and support. They explored new approaches and laid the foundation for future breakthroughs. These researchers were often driven by a deep belief in the potential of AI, and their perseverance paid off in the long run. The lessons learned from the AI winters highlighted the importance of managing expectations, addressing fundamental challenges, and ensuring the availability of computational resources. These experiences have informed the strategies and approaches used in AI research today. The cyclical nature of AI research, with its periods of both hype and disillusionment, reflects the complexities of developing intelligent machines. Each cycle has brought new insights and advancements, contributing to the overall progress of the field. Each winter has ultimately led to a deeper understanding of the field and paved the way for new waves of innovation. The setbacks have been instrumental in refining the goals and methods of AI research, ensuring that the field continues to evolve and grow.